Hello. Today I will show you how to make your daily work with the Django project in a Docker environment much easier by creating handy shortcuts in a Makefile and aliases in the terminal. We'll go through the most commonly used commands, add your own targets, and you will also see how quickly you can rebuild the environment when something goes wrong. Finally, we will work with tests, including running them in multiple threads to speed up the development process. But first, a small request. If you enjoyed these episodes, please subscribe to the channel and give it the thumbs up. This way I'll be able to prepare even more materials like this for you. Alright, let's get started. To run the backend in a Docker environment, we use the command you have already seen in previous episodes. Sudo docker-compose-p vetapp-f and the Docker file ends with up. Once executed, the application starts inside containers and any missing images and dependencies are automatically pulled. Starting the app is very straightforward. We can launch the backend practically at any moment. So it's not a problem to clone the repository and start the application within a few minutes. Additionally, just as a quick side note about the command itself. First, if you are using a newer version of Docker, you can write docker space compose without the hyphen instead of docker-compose. Second, sudo is only needed if you are not part of the Docker group. You know how to check if you are in a Docker group. Third, remember that running app without -d starts it in the foreground, while adding -d let it run in the background. -d stands for detached mode. And finally, --build is useful when you have modified the Docker file or the source code and want the images to be rebuilt. We will go back to --build in a few minutes. Let me show you a simple trick that's worth using when working with an application, especially a Docker-based Django application, where in a day-to-day development we often run many different commands. In such cases, it's a good idea to prepare shortcuts for these commands. One way to create a collection of such shortcuts is to use a Makefile. This is a file with no extensions, and that's important. By convention, its name is written with a capital letter, although using lowercase will work as well. So let's go ahead and create a Makefile. In this file, the Makefile, we define targets line by line, writing their names followed by a colon. Under each target name, with proper indentation, we specify the command or commands that should be executed when the target is run. For the run target, we enter exactly the same command that starts the backend application environment as shown earlier, exactly as you can see in the video. With the file prepared like this, we can start using it. Now, we no longer need to type out the entire long command to launch the development environment. A simple sudo make run is enough. As you can see in my video of the Makefile, the command itself already contains sudo. So adding sudo make run is technically redundant. But well, that's just one of my habits. I've been typing it this way for years. Usually I don't put sudo directly inside commands in a Makefile, but in this case it doesn't bother me. Just as a side note, if you add sudo inside the Makefile command itself, you don't need to type sudo again when running it with make. Alright, let's stop the development environment and make our lives a bit easier. The sudo make run command is something we will probably use every day, at least a few times. So let's make a shortcut. Let's add an alias just like we did in the previous episode. To do this, we open the bash rc file with any text editor. In my case, I'm using Nano for this example. As you can see, I already have a few aliases in this file that I use daily and that make my work much easier. For example, sudo make run is shortened to smr, sudo make to sm, yarn dev for the frontend environment is yd, and yarn dev-o, which opens the browser immediately, is ydo. You can add similar aliases in your bash rc file. They will definitely come in handy. I will be using them later in the course, so it's worth setting them up now. With these aliases in your bash rc file, every time you start your computer, they are ready to use right away. Just type the shortcut you added, in my case smr, and the backend application development environment starts immediately. In a similar way, we can start the frontend environment. The ydo command launches it immediately and also opens the browser. And as you can see, that's exactly what's happening now. So, simple shortcuts and aliases combined with the Makefile, I think, can really make our lives and daily work much easier. Alright, let's close the front-end and backend environments for now, since we don't need them at the moment. I'd like to add a few commands to the backend Makefile that, in my experience, are very useful in everyday work, especially in a Docker environment. One important command is running database migrations, so we add a migrations target and under it we put the command that will be executed to run migrations after changing models or adding a new one. The command starts as usual with sudo docker compose with optional -p and the project name and -f docker compose file options, then run --rm, which automatically removes the container after the command finishes. Next, we specify the container name where the command should be run, in my case Django, and finally the command python manage.py make migrations. As you remember, we have the sm alias, which is simply a shortcut for the sudo make command. We can use it by adding the name of the target we want to run. For example, to run a migration, just type sm and the migrations. Another commonly used command is of course the database migration, which we run using python manage.py migrate. We can simply copy the previous command and add the appropriate target. The next frequently used commands are those related to handling translations in Django, namely make messages and compile messages. If you are new to Django and don't yet know exactly what these commands do or how they work, don't worry. Later, I will show you an example of how to create an application that responds to the frontend in multiple languages. Since our application will be multi-language, we will definitely be using these commands often. Another important target that we will likely use often is build. It's responsible for building the containers and the entire Docker environment, and thanks to it we can run and test the application locally, so let's add a simple build target. Alright, we have now reached what I believe is the most important target we will be using, testing the development environment. In other words, testing the application. To run tests in an application created with the Django cookie cutter, if you have just joined the course, you can follow along in the previous episodes. We use the pytest command. We run it inside the Django container. This command is already prepared. We don't need to create it ourselves. If you generated your project with the Django cookie cutter, it is ready to use from the start. So let's add the test target with a command that runs pytest in the Django container. Let's run the test, and as you can see, there is an error. Okay, I see the issue. I typed sudo instead of sudo. Let's fix the typo, and now after running the tests with the sm tests command, you can see the application executing its tests. The Django cookie cutter provides some basic user-related tests by default, but we will of course be writing our own as well. Right now we don't have many tests in the project, but in typical Django applications and in production applications in general, if we are building an API, we usually test practically all scenarios and API's actions. Naturally, that means we can end up with quite a lot of tests. To run them faster, we can add the -n flag and specify the number of processes that should run in parallel. I usually set it to 4, which splits the test into 4 threads and then run simultaneously, significantly reducing the total execution time. However, this doesn't work by default. To make it work, we need an additional library that enables parallel test execution. The library that allows us to run tests in multiple threads simultaneously is pytest xdist. At the time of recording this video, it's available in version 3.6.1. So, let's add this library to the requirements file, usually requirements.txt. In applications created with the Django cookie cutter, this is neatly split into 3 parts: local requirements, production requirements, and the base requirements. This approach ensures that we don't install unnecessary libraries and packages in the production environment where they are not needed and would only put extra load on the application. For now, I am adding pytest xdist to the local requirements. When we get to building the automated deployment process, which will include a step to run tests before updating the application on the server, we will add it to the production requirements as well, so it's available in the environment used by the deployment process. We will come back to that later, as there is still going to be some time before we discuss that topic in detail. Let's pause here for a moment, because we have got some new commands I'd like to go over. In the meantime, I have been experimenting with my Docker environment and Docker in general, and in the process I managed to break my application setup. But that's not the problem, and this is exactly where I want to show you how quickly and easily you can rebuild the application even if you mess something up. As you can see, the first command is simple. It's used to launch the Django shell. I have added it because it's handy. By running sudo make shell, we got straight into the Django's shell within the context of our application. But that's just a small thing. The more important part here is a clear Docker target. In this target, I'm using the docker compose down command with a few extra flags. You are already familiar with the -p and -f flags, so I won't go into them again. The down command stops and removes containers, networks, and images associated with the project. In this case, that app. But only those created by Docker Compose. It doesn't touch anything else, so it's a safe way to clean up our application's environment. The --remove orphans flag removes so-called orphans containers. These are containers that belong to the app project but are no longer defined in the current Docker Compose local.yml file. This can happen occasionally when we change the container definitions in our compose file. Next, the --rmi all flag removes all images associated with this project, both locally built ones and those pulled from the registry. And now the key question, why is it safe? Because this command only removes containers and applications files. It does not remove volumes such as our database. So to remove volumes, we would need to add the --volumes flag. If we did that, we would lose all our local data and would have to re-enter it from scratch. But since that flag isn't here, all volumes, including the PostgreSQL database used by the application, remain untouched. That means when we restart the containers, the applications can use the same database as before, giving us a fresh environment but with our data intact. This makes the command perfect for quickly cleaning up local containers and images without the risk of losing any data. Okay, we cleaned our environment using clear Docker, and as you can see, everything is working correctly. The containers were stopped and then the images were removed. Let's now build our environment using the smbuild command. After a short build process, we will start the application using the smr alias we created earlier or the full sudo make run command. As you can see, everything is working correctly. The individual containers are starting up properly and the application is slowly coming online, as specified in the docker compose.local.yml file. Here we can see our application and a container named vetapp backend local Django. I will copy this name as it will allow me to prepare the last command in the Makefile that hasn't been completed yet. The command docker exec-it followed by the container name and bin bash starts an interactive bash shell inside the specified container, allowing you to view or modify the application's files. The -i flag keeps the standard input open and the -t flag allocates pseudo TTY enabling interactive shell usage. This command is rarely used and is typically reserved for serious troubleshooting or when performing very detailed analysis and verification. With the application running and the Django container app, we can enter it and, for example, check what files it contains. To do this, we use the smbash command we prepared a moment ago. Okay, let's stop the application. If we check the status of our repository using the git status command, we can see that there are changes in the requirements local.txt file and a new file Makefile. We will deal with that in a moment. For now, I would like to show you one more thing we have changed, the test run output. Using the sm alias we created earlier or by typing the full sudo make command with the test target, the application will run its stored test. As you can see, this time we no longer have the error related to the -n4 flag, which allows the tests to run in 4 parallel threads. This may surprise you a bit. The tests took about 9 seconds to complete. Last time when we ran them without this library and without splitting into 4 threads, they finished it much faster in around 3 seconds. This is because preparing the threads and splitting the tests takes some additional time. With a small number of tests, this is indeed a loss. But for large projects where the entire application is tested, the time savings during execution will be significant. Alright, to wrap up, let's add our work to the repository so that nothing gets lost or broken. This way, others working on the project will also have access to the changes we have made. To add files to the repository, we use the git add dot command. This will add all the files we have changed or created. Then we prepare a commit. The git commit-m command allows us to add a comment and a description for the commit. Commit messages are very important. Here I may be writing one that's a bit too detailed, but we should always make sure that they are clear enough so that others viewing the repository and checking the history of changes can easily understand what was modified in each commit. This is especially useful, for example, when we want to use a cherry pick, something we will definitely revisit later in the course. With the commit prepared, we pushed it to the repository using the git push command. Hooray! Done! We no longer have to worry about our changes disappearing or being lost. They are safely stored in the repository and we can return to them at any time. Everyone working on the project will also be able to benefit from them and from the conveniences provided by the Makefile we have just created. And that's all I have prepared for today. In this episode, we launched the backend in Docker, set up a Makefile with a set of practical targets, added aliases to shorten everyday commands, tested the application, including running tests in parallel, and learned how to clean and rebuild the environment without losing any data. Finally, we committed our changes to the repository so they are safe and available to the whole team. And of course for you. In the next episode, we will go back to the beginning of the changes we temporarily paused and return to working on the front-end application. We will also discuss and implement Pinia storage in practice. Thanks for watching and as always, see you soon.